Welcome to Class 10, Chapter 11, Constructions. Today we'll be discussing a new topic, which is construction of tangents to a circle. How to construct tangents to a circle when the point from where we have to construct the tangent is outside the circle. Suppose you are given a circle with center O and a point P outside it. Now we are going to construct two tangents from the point P to the given circle. We will discuss what are the steps for this construction. The first step is, first we will draw the circle with center O and take a point P outside it. Drawing a circle with center O using a compass with the given measurement of the radius. Okay. So here I have taken a random measurement just to show how to do the process. And taking the point P outside, anywhere outside the circle. Take the point as P. Now the first step is you will join PO and bisect it. Bisect it in the sense you have to find out the midpoint of the line segment OP. So using the perpendicular bisector method, that is using the compass, taking the compass, take the measurement more than half, mark an arc in the upper and lower part with the compass fixed at O and then fixing it at P with the same arc measurement. Mark the arcs in the upper and lower part. So after the process of taking these arcs, you will get the points of intersection of the two arcs. Now we'll mark those 2 points of intersection, join them using a scale. And when we join these 2 points, that line will touch somewhere at OP. Mark that point as M, and this M will be the midpoint of the line PO. So this is your first step of construction. Now second step is you have to take M as the center and MO as the radius and draw a circle. M as the center and MO as the radius. When I say MO as the radius, MP is also the same length. So M should be the center, drawing the circle. Now this is intersecting, this new circle is intersecting the given circle at some point, at 2 points, right? Those 2 points we will mark as Q and R. Now the next step, that is the third step, is to join this point Q to P. That is join PQ and the point to R, sorry, the point R to P, that is PR. Join PR. So these red lines are the required two tangents, that is PQ and PR. Now we will see that how this works, that is how we are saying that the two lines which we got now, PQ and PR, act as the tangents to the circle. For that we are giving the justification. Again, take the figure, there we will join OQ with a dotted line, because this is only for justification purpose, it is not in your construction part. Okay, so we are just joining OQ with dotted line. Now you can see that this PQO is a triangle in a semicircle. You just see the bigger circle, there it is a triangle in a semicircle, and angle inscribed in a semicircle is always having 90 degree. So you can say that angle PQO is equal to 90 degree. Now we have a theorem which states that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Here in the figure, the point of contact is Q, and through that the radius of the circle with center O, which is given in the question, that is there. So the radius OQ, and it at the point of contact it is getting an angle of 90 degree. That means this PQ, the line PQ, should act as a tangent to the given circle. So OQ is the radius of the given circle. Hence, PQ should be the tangent to the circle. Similarly, you will have PR also to be a tangent to the circle with the same concept. When we join OR, you will get 90 degree at R, and with the same concept, with the same theorem concept, you will get that PR is acting as a tangent to the circle. Now we will start exercise 11.2. In each of the following, give also the justification of the construction. First question is, draw a circle of radius 6 cm. From a point 10 cm away from its center, construct a pair of tangents to the circle and measure their lengths. Now first we will write the steps for construction, that is, we have to draw the circle of radius 6 cm. And mark the center as O. So using the compass, taking 6 cm, drawing a circle with center O. Now we have to take a point such that OP, the point P, should be 10 centimeter away from the center. So we will just take OP as 10 centimeter where P is somewhere outside the circle. So that is your second step. Mark the point as P, which is 10 centimeter away from the center. So now OP is 10 centimeter. Next, third step is you have to draw the perpendicular bisector of OP. That is, in order to find out the midpoint of OP, we are drawing the perpendicular bisector of the line segment OP. So from the point O, taking more than half length of the length OP, mark two arcs in the upper part and the lower part. Then again from the point P with the same arc length, mark the arcs. You will get 2 points, join them, and joining them, that line will intersect OP at some point. Mark that point as M, which will be acting as the midpoint of OP. Now again considering center M and MO as the radius, we are drawing a circle which cuts the given circle at 2 points, which we will mark as Q and R. So the fourth step is with center M and radius MO, draw a circle which cuts the given circle at Q and R. So those are the 2 points Q and R. Now the next step is you have to join the point Q with the point P, that is join PQ. And then join PR. So you can see that PQ and PR which you got are the required tangents. Now we will give the justification of what we have said. That is how we are saying that PQ and PR are acting as the tangent to the given circle. First, we'll join OQ. So you can see that angle PQO is an angle inscribed in a semicircle. Therefore, this angle will be 90 degree. Angle PQO will be 90 degree. Now again with that theorem itself, if OQ is the radius of the circle, and at the point of contact you are having a perpendicular, that is 90 degree. This PQ should act as a tangent to the circle. So since OQ is radius, PQ is a tangent to the circle. Similarly, PR is also a tangent to the circle. Now they have asked to measure the lengths. By measuring means you can just use your scale and measure it. You will get PQ as 8 cm and PR as 8 cm. That means the length of both the tangents will be equal. Next is question number 2. Construct a tangent to a circle of radius 4 cm from a point on the concentric circle of 6 cm and measure its length. Also verify the measurement by actual calculation. First we will start with steps of construction. So what are you given with? That will be your first step. That is, we will draw two concentric circles of radii 4 cm and 6 cm with the common center O. Next is, you have to take a point P on the bigger circle, that is the circle with radius 6 cm, anywhere on that circle, and you have to join OP. Now what we will do? We have to take the perpendicular bisector of the line OP as we have done in the earlier problems. Then we have to join those two lines. That will give you that midpoint as M. That is, the midpoint of OP will be M. That is the perpendicular bisector of OP. And with M as center and MO as radius, draw a circle which will be intersecting the smaller circle, that is the circle with radius 4 cm at Q and R. So 2 points where they are intersecting, mark them as Q and R. Now the last step will be, you have to join the point Q to P and the point R to P. That means join PQ and PR. Hence you can say that PQ and PR are the required tangents to the smaller circle. Now they have asked to measure the length. Now measuring the length, you will get PQ as well as PR to be 4.4 cm approximately. Next comes the justification part, in which again you have to justify why you are saying PQ and PR to be the tangents to the circle. First we will join OQ, and at the point Q you will have 90 degree for angle PQO to be 90, since it is an angle inscribed in a semicircle. Therefore, with the same argument, you can say that PQ should be a tangent to the smaller circle, and hence PR also will be a tangent to the PR also will be a tangent to the same circle. Now we will just find out by actual calculation what will be the length of PQ. When they say actual calculation, you have to use your Pythagoras theorem, because PQO, angle PQO is 90 degree. So you can use Pythagoras theorem to find out the length PQ, which will be root of OP square minus OQ square, which is equal to root of 6 square minus 4 square, equal to root of 36 minus 16, which is root of 20, which is 2 root 5. So the value which you are getting is an approximate value, which is 4.47 centimeters. Thank you.